When building GFDTs, unlike with FDTs, there are two things we can change. These are the class width and the first lower class limit. To use an analogy, this is saying we get to decide how big of a step we will take while walking, and we also decide where we will start walking from. The step size is analogous to the class width. The starting point is analogous to the first lower class limit. The key to remember is that if we change one or both of these, we may end up with a different GFDT. However, it is still the same data set. It is just being presented in a slightly different format. Here we will look at 4 different GFDTs with different class widths. We will notice that as the class width gets bigger, the GFDT overall gets smaller because it will have fewer rows. Continuing with our analogy, it doesn't take as long to get where you're going if you take bigger steps. In our first GFDT, we have a class width of 4. Again, this can be easily obtained by subtracting 2 consecutive upper class limits, like 120 minus 116, or 2 consecutive lower class limits, like 114 minus 110. You may also recall that we could also subtract consecutive class midpoints or class boundaries. However, the one thing we do not want to do is subtract the lower and upper class limits from the same class, such as 120 minus 118, which gives a value of 2, because this will always give a number too small for the actual class width with discrete data. There's another point that we should reiterate about this data. Recall, each correct question on this exam was worth 2 points. So a class width of 4 actually only represents 2 data points. For example, the class of 106 to 108 actually only contains the values 106 and 108, 2 values, but the class width covers 4 units, in other words, 4 points on the test. One of the reasons to look at a GFDT, or in this case the tally plot for the GFDT, is that it shows us something of the shape of the data. In this case, we might describe the data as a bimodal data set where there appear to be 2 humps in the data. The major mode is around the high 90s and lower 100s, and the minor mode appears around the mid 70s. Next, we will look at a GFDT with a class width of 6, which, for our data, is a total of 3 possible data values appearing in each class. As expected, the GFDT is smaller with fewer rows. However, the general shape descriptor still holds, a bimodal shape with a major and a minor mode. The modal class, the class which has the largest frequency, has also been highlighted in this plot. Using the definition for the mode for a GFDT, we find the midpoint of this class, which would be halfway between 92 and 96, or 94. Curiously, we recall from a few slides back that this is indeed the traditional mode for this dataset. Let's continue the process. We next change to a class width of 8. Again, we have a GFDT with fewer rows, and we still observe the general bimodal feature, though the major and minor modes appear to be getting closer. And here we have the GFDT for a class width of 10. We have fewer rows, and we still have a hint of the bimodal feature with the major mode in the 90s and the minor mode in the 70s. Before we dissect this display a bit further, I will note one small curiosity. While the class width was the only thing that changed in these plots, you may have noticed that the lower class limit also changed. Well, that is true, but if you note the largest upper class limit for each plot, this value, 120, the maximum possible score in the test, did not change from plot to plot. It is a good thought exercise to reflect on how these classes and GFDTs might change if we had fixed the initial lower class limit of, say, 38 for all of the GFDTs and the tally plots. First, we can confirm that the class width is indeed 10 by subtracting any consecutive pair of lower class limits or consecutive pair of upper class limits. We already noted the bimodal nature of the plot, which might be perceived as more of just a right or negative skew, as the major and minor modes appear closer here. We can also look at the modal class, 92 to 100. Again, the class width is 10, but there are only 5 data values possible in each class. In this case, 92, 94, 96, 98, and 100. The midpoint of this class is 96, and this could be the reported mode for this GFDT, which is not quite exactly the true mode of 94 for the raw discrete data, but it is rather close. This brings up one key issue with GFDTs. We sacrifice information for a more concise plot. That is to say, there are 118 data values in the range of 92 to 100 for this data set. You're happy to count the tally marks if you don't believe me. But from this data summary or graphic, we have no idea of how those 118 values are split among the possible 5 values in that class. While unlikely, it could be the case that all 118 values are the exam score of 92. The key takeaway message is that we can't say specifically what each of the 118 values are. We can only say that there were 118 values between 92 and 100. At least not without being able to also reference the original GFDT or the raw data.